Hello everyone, this is Trisha Naik from TE Electronics, and today I'm going to be designing inverting and non-inverting amplifiers using LTSpice. So to begin with, let's open the LTSpice tool. Go to File and click on New Schematic. This should open up a new page. So first, to choose our op-amp, I am using OP07. So I will go, this is the component, this is for components, so I'm going to go to components and type in OP07 and enter. So I place my OP07 here. Now the next thing I need are resistors. So this is the shortcut for resistors. So I'm going to click here and I can use this icon to rotate my resistor. I'm going to need 2 resistors for my design. Now I'm going to use wires to join whatever I have put on the screen till now. So I've done this much of wiring. So now I'm going to put in my sources. So I go to components again and type in voltage since I want a source. So I put one here. I'm doing an inverting amplifier first. So I've applied input to the inverting terminal. And I also need VCC and VEE supplies. So I'm putting in 2 for the VCC and VEE respectively. Now I'm going to do the rest of the connections as well. Now I need to put in my ground. So this is the symbol for ground. Now I need to give the supply voltage to the op-amp. So I'm going to take out wires from here. Now I'm going to right click over here and go to label net, and I'm going to label this as VCC and connect it here as well as here. Alternatively, you can also connect this terminal over here using wires, but I'm doing this just so it looks a bit neater. Similarly, I will right click here, go to label net and give it as VEE and connect it here as well as here. Now I'm going to give in the values for resistors as well as the supplies. So starting here, I'm going to make this 15 volt and this 15 volt as well. Then I'm going to give this resistor as 1K, and since I'm designing right now for a gain of 2, I'm going to be giving the feedback resistor the value of 2 kilo ohms. Since the formula for gain is for an inverting amplifier is RF by RI. So this is my RI, this is my RF. So 2K upon 1K should give me a gain of 2. So now I am going to, since we need an AC voltage here, we go to advanced and go to sine and giving a sine input here. We are going to give a DC offset of 0. I'm giving an amplitude of 2 volt and the frequency of 1 kilohertz. So our circuit is ready. Now I'm going to run it. So over here I'm going to give it as 3 millisecond and enter. So here I need to give an input and output in case I need my waveforms with a label. So I'm going to go ahead and I need to close this first. I'll go ahead and right click here and go to label net again and label this as V in and connect this here, and go here, right click again and label this as V out and connect it here as well. I'm doing this so the outputs which I get are with a label. So now I'm going to save and run this again. So my first marker should be where I've given my input voltage, which is V in. As you can see, I've gotten my input voltage, and the other would be V out. So my green wave is the input and my blue one is the output. So as we can see that I've given an input of 2 volt and gotten an output of 4 volt. That means a gain of 2. So similarly we can change the input voltage here as well as the gain, the value of the feedback resistor here to get outputs of different values as well as different gains. So here is my inverting amplifier with different voltages given as input, and these are the values which we get as output practically. Similarly, we can give other inputs as well to get similar outputs, and we can also change the gain by changing the value of RF for an inverting amplifier. Similarly, as we designed an inverting amplifier, we can also design a non-inverting amplifier, but in this case the value of R1 would differ because the value of the formula for gain for a non-inverting amplifier is 1 plus RF by R1. So the value of the resistor would have to be taken accordingly. So similarly, I have given various values for input and gotten output values. These are the inputs, these are the outputs. So as you can see, the outputs for the inverting and non-inverting amplifier are similar, but for an inverting amplifier, the output can be seen with a 180-degree phase shift, whereas for a non-inverting amplifier, this is not the case. Similarly, for a different gain, I have changed the value of the resistor and gotten different outputs as well. For the last part, for a gain of 5, it is observed that when the output exceeds the saturation voltage, we get a clipped waveform as shown here. So the output here is for an input of 5 volt. So here we can see that as the output voltage exceeds saturation, we can see a clipped waveform. So in this way we can design inverting and non-inverting configurations using an OP07 op amp, and that's it. Thank you.